So we just learned about the arithmetic sequence, am I right? We have another type of sequence that we call geometric sequence. So let's write them side by side. So when it comes to computation, analysis, we can easily distinguish between these two. So you have sequences. Well, you have an arithmetic sequence. And then you have geometric sequence. So for arithmetic sequence, you learn that you have A1, A2, AN, and the rest of the terms. You found a common difference between the terms. A2 minus A1 is the same as A3 minus A2 is the same as AN minus AN minus 1. So you have a common difference between them. The general term of your sequence is A1 plus N minus 1 times the common difference. You can find the sum of the first N terms by dividing N by 2, multiplying that by A1 plus A sub N. Then in arithmetic sequence, you have another sequence that we call geometric sequence. So basically, if you have the terms of the sequence, A1, A2, A3, and AN, and the rest of them, you're going to have a common ratio. What is a common ratio? If I divide A2 by A1, it is equal to a fixed number like R that we call common ratio, which is the same as A3 divided by A2, which is the same as A4 divided by A3, which is the same as AN over AN minus 1. So here you have a common difference. The difference is the same. Here the ratio, the division is the same. So common ratio, common difference for arithmetic sequence and common ratio for geometric sequence. Please note that R is not 0. Very good. So as we wrote down the general term for arithmetic sequence, let me write down the general term for geometric sequence. F of n is equal to, you're taking the first term of your sequence, multiply that by R to power n minus. And again, remember that R is not 0. Give me an example. So for example, related to arithmetic sequence, what did you have? You have 7, you had 11, you had 15, 19, and so on. The difference between the terms were the same. D was 11 minus 7, which was the same as 15 minus 11, which is the same as 19 minus 15, and so on. And f of n, as you remember, is 7 plus n minus 1 times d, which is 4. Or f of n, as you remember, is 4n plus 3. Now, one example here for you, analyzing the geometric sequence. In this case, in this scenario, I'm going to give you the following sequence. I'm going to give you 2, then 4, then 8, then 16, and so on. Well, the very first term is 2. The second term is 4. If I do the subtraction, 4 minus 2 is 2, but it's not the same as 8 minus 4, which is 4. So it is not an arithmetic sequence. Not an arithmetic sequence. Not arithmetic. Well, take a look at the ratio. 4 divided by 2, 8 divided by 4, 16 divided by 8. So 4 divided by 2 is 2, which is the same as 8 divided by 4, which is the same as 16 divided by 8, and so on. So you have a common ratio. The common ratio R is equal to 2. So if I punch them into this formula, I can find the formula for a geometric sequence. F of n is equal to A1 is the very first term, 2. 2 times what? 2 times R to exponent. What is R? R is 2. What is the exponent? N minus 1. Can I simplify this? Now you have to do algebra to simplify, as you did here, algebra to simplify. So remember that if you have a to power n times a to power m, algebra says you can write one base and add the exponents. This is 2. The exponent is invisible. It means that the exponent is 1. So f of n is written as 2 to power 1 plus n minus 1. So f of n is nothing but 2 to power n. This is the general term for this geometric sequence.